Okay, so the 1943 Nobel Prize in Physics. I know you're asking me, hey, Dr. Imholt, where's 1940, 41, 42? There was no physics prize in 1940, 1941, or 1942 because World War II. Now, I think a lot of people, when it comes to World War II, kind of just sort of, oh yeah, the whole thing. I don't think the scale of it is really understood by the modern world. There was not a country on the planet that was left untouched by this thing. Maybe a few, but there weren't many places on the planet that were untouched. Either they were sending troops, they were sending supplies, supply depots at them. Families all over the world had either people serving, they'd lost family members. It was a mess, and a lot of things around the world stopped and focused solely on that. There was nothing else going on except for the war. And there's not been an equivalent of it since then. Everybody likes to equate the war on terror to World War II. It's not remotely the same scale. I get that, certain things today, there's a lot more danger because of some now technologies gotten a lot further, but the prize was not done in those 3 years because of World War II. In 1943, they decided to award it to Otto Stern, who you see behind me. He didn't receive that prize until sort of late 1944 somewhere, but the decision was made in 43. So it was actually, he got the award much, much later than he was actually, the announcement was made. He was awarded the prize for his contribution to the molecular ray methods and his discovery of the magnetic moment of the proton. I'll get to all that in a minute, but I want to point something out, that he was actually, Otto was born to a Jewish family in the middle of German Empire, someplace, but had moved to the United States before the war. He was at Berkeley, and did all of his work here. He went back and forth for a while in between Europe and the United States, but around the mid 1930s, I don't think he ever went back, because I think a lot of people saw things coming and they didn't want any part of it. His contributions were kind of interesting. If you want to look him up, there's a whole lot of philosophical stuff he worked on as well outside of physics. It's not going to be any part of this discussion, but it is out there. It is very interesting stuff. He's also holds the record for being the second most nominated scientist around. So he was nominated a bunch more times than he actually won. He won once, but he'd been nominated a while. I think he was nominated for a chemistry prize as well. But let's dig into what the heck it was he did, and what is a molecular ray, and what is the magnetic moment of a proton, both of which matter. So let's go. So what the heck is magnetic moment, and what's it got to do with a proton? Well, put simply, it's how much will the proton itself interact with a magnetic field. And how the heck did he do that? Well, he used a hydrogen gas cloud to form a beam, and then looked at it as it went through a uniform magnetic field, and the deviation of that proton beam from where it started versus where it ended allowed him to calculate what that magnetic moment of the protons are. That also led him to the molecular ray. So let's take a look at that. So first you need to start with a gas. It could be silver, it could be hydrogen, it could be a molecule. You heat it up, you get it all moving in the same direction. You could do that with some sort of an electric field. You get a beam coming out, then you pass them through a magnetic field, and that magnetic field sends them in some direction. And the point to this experiment originally was they used it to have another proof of quantum mechanics. So you get one result from classical physics if you calculate it, you get another one from quantum physics, and of course this is down at the quantum level, so you get the quantum result, you don't get the classical result. And that allows you to use those beams to figure out different things, like the magnetic moments of all the different elements, the magnetic moments of different molecules. And he used that same technique to come up with a molecular ray. Now, it sounds like a crazy military weapon. Don't worry, it's not. But what might you use a molecular ray actually for? Well, all sorts of things, but let's take a look at one that I've actually used myself. Well, in modern labs, molecular beams or molecular rays are actually used for this process called molecular beam epitaxy, which typically takes place in big piles of stainless steel vacuum systems like you see here. Now that's used for a variety of things, including thin film deposition, single crystals, all sorts of stuff that I can go into deep discussions on, scientific gobbledygook that most people won't understand, and that's okay because you don't need to, because you don't work in these labs. But it's used to make things that you have used: diodes, field effect transistors. It's all done at microwave frequencies, but All of this stuff is actually used in the semiconductor industry to create devices that you have used on a regular basis, because you wouldn't be able to use your cell phone if there wasn't somebody on the other side building the devices inside it. And oftentimes in the modern world, that's done using molecular beam epitaxy. So there you go. You do owe a lot of thanks to some of these earlier Nobel Prizes, and the electronics industry would not exist today as we know it without this particular one. So while this prize seems pretty simple and it looks like, oh, he made, that would have been done anyway. That seems simple, 80 years after the fact, but without the work like this, like I said, we wouldn't have modern electronics. We wouldn't have proton beam therapy. We wouldn't have a lot of the things we use today in ways that people don't realize they're using them. And to me, that's the best invention. That's the best sort of science, the best sort of technology, is you're using something you don't realize you're using. If you remember back about 10, 20 years ago, nanotechnology was the big thing. We were nanotech this, nanotech that, nanotech the other thing. And all of a sudden it sort of went away. Well, the reason is you're using it. It's in your phone, it's in your devices, it's in your computer, and you don't realize you're using it. And that sort of technology that you use and you get the advantages of it, you don't really realize that you're using it. That's the cool stuff. This is one of those sorts of things. It's used all the time in many, many places. You don't even notice it anymore. It's so commonplace. But that to me is the cool stuff, is the guy that came up with the thing that everybody uses and they don't realize they're using. So this one to me is pretty darn cool. And as we get out of the World War II era and into sort of later stuff, you'll see a lot of things that are a lot different. So from here on out, the prizes are going to be a little bit different because we're coming into more modern technology. So as we get into sort of the 50s and 60s, you'll see some great differences. And then we get into the 70s and 80s, it's even bigger differences between this type of technology and what's coming. So stay tuned, lots more to come. Please don't forget to click subscribe and like. It does help us out with the algorithms, and we'll see you on the next one.